This is an explanation of your homework on page 208. And so I'll just read through the problem first and then show you my solution. So you had problem number 1, which says that the equation is given as y is equal to 3x plus 5. In part A, you're given that dx dt is equal to 2, and you want to find dy dt when x is equal to 1. And then part B is given that dy dt is equal to negative 1, find dx dt when x is equal to 0. Okay, so y is equal to 3x plus 5, so I'll take the derivative with respect to time. So dy dt is equal to 3 dx dt, and then the 5 will just drop out. So you're given that dx dt is equal to 2, so substitute that in for this right here. So you get dy dt is equal to 3 times 2, which is equal to 6, and that is equal to dy dt. Now in this problem, the given information that x is equal to 1 is irrelevant because x does not appear anywhere in the derivative. The second part of this is, I'll use the same derivative, so dy dt is equal to 3 dx dt, and this time dy dt is given as a negative 1, so I substitute negative 1 in for dy dt in this equation, so you get negative 1 is equal to 3 dx dt, so dx dt is equal to negative 1/3. Okay, next problem is question 13. Oil spilled from a ruptured tanker spreads in a circle whose area increases at a constant rate of 6 square miles per hour. How fast is the radius of the spill increasing when the area is 9 square miles? Okay, so I'm going to start off with the area of a circle being pi r squared, and then taking the derivative with respect to time would be dA dt and equals 2 pi r dr dt. You're told that dA dt is equal to 6, and then let me go back to what the given is here. Okay, and then how fast is the radius of the spill increasing when the area is 9 square miles? So then I'm going to be using 6 is equal to, and I need to go back and figure out what the radius is when the area is equal to 9. So then the area is equal to pi r squared, which is equal to 9. So then solving for r, I would first of all divide by 9, and then take the square root. So r is equal to the square root of 9 over pi. And then I put it back into this equation right here. So dA dt is given as 6, and then that is equal to 2 pi. And then the radius is the square root of 9 over pi times dr dt from this. So simplifying this, square root of 9 comes out to be 3. So 3 times 2 is 6. And then I have a square root of pi in the denominator and a pi up in the numerator, which simplifies to a square root of pi in the numerator. And then I solve for dr dt, so that gives me 6 over 6 times the square root of pi. And then simplifying that, the 6's cancel out, so dr dt comes out to 1 over the square root of pi miles per hour. Okay, the next question is problem number 15. So in 15 it says, a spherical balloon is to be deflated so that its radius decreases at a constant rate of 15 centimeters per minute. At what rate must air be removed when the radius is 9 centimeters? So I'm going to first of all start with the volume of a sphere, which is 4 pi over 3 r cubed. And then take the derivative, so it's dV dt is equal to 4 pi r squared dr dt. Dr dt is given as negative 15. And the reason that it is negative is because it says that it is being deflated. So that means it's decreasing at a constant rate of 15. So that word decreasing means that it's going to be a negative. And then the radius is going to equal 9. So then dv dt is equal to 4 pi 9 squared times a negative 15. And then simplifying all of that, dv dt comes out to negative 4,860 pi cubic centimeters per minute.